Hey YouTube, and welcome back to It Just Clicked. In our last video, we talked about the variable x in the first dimension. In this video, we're going to be talking about the variable y and entering the second dimension. In order to talk about y, we need to talk about the distinction between an independent and a dependent variable. X is a good example of an independent variable. Like we talked about in the previous video, you can have anything for x. You can choose the number for x if you'd like, or you can place x into a problem where you don't know what the answer might be. But the point is, x can be anything. It's just that sometimes it is a particular number. However, that's a lot different than y. Y is a dependent variable, meaning whatever the value of y is will be determined by the value of something else, most of the time the value of x. And because y is determined by the value of x, a lot of the time how we'll write this is y equals something, and that something will usually be in terms of x. So maybe y equals 2x plus 1, or y equals x plus 2, or even just y equals x. But you might be asking yourself, okay, but what is y then? Sometimes you'll hear y described as a function of x. And a function in this example is basically an equation. So like I was saying before, when we say that y might be set up as y equals 2x plus 1, we might also say there is a function of x, and the function of x is 2x plus 1. Because remember, y is always based on what x is. So we can say a function of x, since once we find x, we can find y. And you might be thinking, why not just use y, since it's a lot simpler, since function of x is a whole complicated name. But I think that seeing it in terms of a function of x makes it a lot easier to understand what's actually going on here. So basically, anytime you see y, you're going to see it in terms of x or as a function of x. So like I said before, you might see y equals 2x plus 1 or something like that. But what's important to note is that's how you're basically always going to see y. Y is always going to be set up in a function like this because that is the nature of a dependent variable. It's a little bit different than what we've been doing previously, so let's get into it. So the first question might be, okay, how do we write all of this? Because how we've written it before is we set up an equation and then we solve for that equation. But what it sounds like in this instance is there could be more than one answer to our equation, since we can plug in different numbers for x. And that's definitely true. So a lot of the time when we solve an equation like this, we might solve for more than one value for x. Instead of just putting one value in and solving it, we might try 3 values or 4 values to see all of the different outputs or answers that we get. This is an important concept known as substitution. And when you think about it, what we're doing is we're substituting a value. So we're taking a value like 0, 1, or 2, and we're placing it in place of x. So we're substituting the value for the x. The x won't be there anymore, and the value will be there instead. And then we can solve the equation. The easiest way to show this is to draw a table. So we'll have a table with 2 columns. One column will be the y column, the other column will be the x column. And basically what we do is for each particular value of x, so let's say maybe 0, 1, and 2, we'll have a corresponding y value. But we have to solve the equation to find the y value, not the x value. If we think about the kinds of equations that we did before, a lot of the time we could only use an equation to find something out in a moment, like how much I paid for something, or how tall I am at a certain point in time. But now when we add in the y and x variables, we're able to track things and measure things over time, which is very important. Let's say for the next month, you have an opportunity every day to work. If you choose to take that opportunity to work, then you will make $50 for that day. If you choose not to work, you won't make any money. And also, your parents will give you a $20 allowance every week just in case you didn't work, but they won't know if you worked or not. So let's see how we would set this up to know how much money we could make over this given month, depending on how many days we work. So to start, we have to determine what will be our x and what will be our y. Well, we know that what we're trying to find is how much money we're going to make if we work or don't work over this next month. So that will probably be our y, since that's the thing that can change, right? If I only work 3 days versus 15 days or 20 days, the amount that I get paid is going to change. So y will be our dependent variable, which will change depending on what our x value is. So then the question is, what is our x value? Well, usually when you're setting up an equation like this, and it has to do with time, so for the example that we gave, the time would be the month that we have for an opportunity to work. We want the time to be broken out by x. So we could say each day that we choose to work could be our x value. So if I work 15 days out of what we're going to call a total of 30 days in a month, if I work 15 of those days, my x value would be 15 when solving the problem. So now we need to find out what changes when I work on a given day, right? Because if x is 1, that means I worked 1 day. So what happens when I work 1 day? Well, if we think back to the original problem, every day that we work, we get $50. So 50 times the number of days that we work will give us our total amount of how much we earned from working. So we can set up our equation as 50x. But we're forgetting something here. We also said that we would get $20 every week from our parents, whether we worked or not. So we have to remember that we've got to add that in somehow. But this $20 isn't dependent on anything. And if you remember what we talked about in our previous video, there's a name for this. It's called a constant, because it will constantly be that number. But we need to make sure that we have the correct constant. So let's look back at our original question and see what our constant will be. So we were told that we will get $20 every week whether or not we work, but we know that we're talking about an entire month, which is 4 weeks. So it's not just going to be 20, because by the end of the month I'll have more than 20. I'll have 20 times 4. So really our constant is 80, because we're looking at this in terms of the entire month. We don't care about 1 week versus another week. We want to know how much we'll have at the end of the month. So now we have our equation, y equals 50x plus 80. And now I can just plug in a number for x that's equal to how many days I want to work that month. So let's say I only want to work on the weekdays and not the weekends, then that's 5 days a week, 4 weeks, which would be 20, right? 4 times 5 is 20. So we could plug 20 in for our x value to see how much money we would make at the end of the month if we worked 20 days, or 5 days a week. So when we substitute our 20 in for x, then we're going to multiply 50 times 20, which will give us 1,000, and then we'll add our 80 that's still there at the end. So $1,080 is how much we would make if we worked every weekday for that month. And what's cool about these kinds of equations is they're actually a lot more helpful practically, because here we could actually determine how much we'll make depending on how many days we work. So if we only wanted to work 4 days a week, or 3 days a week, or 3 days one week, then 5 days another week, all we would have to do is total up the number of days that we worked, plug that in for our x value, or substitute that in for our x value, and then solve. And that way, we can determine how much we'll make before we start working, so we can plan out what our work month is going to look like. If you've ever heard of the term critical thinking, right now there's a really good opportunity to exercise it. You can exercise it by answering the question, how high can x go in this equation? We might think, well, x can be any value, so it could be 1,000,000, 10,000,000, 100,000,000, whatever we want. But the reality is, x here represents something. And what is it that it represents again? X is the number of days worked in a month. So we know that realistically, that number can't be higher than 30. It also can't be lower than 0. Noticing or realizing these restraints is a really good use of critical thinking, because these kinds of restraints show up a lot of the time when you're doing a practical problem that you're trying to solve for. We call them restraints because, in a sense, they hold us back from going further. So, like in the example of hours worked in a month, we're restrained from plugging in 50 for x, because you can't work 50 days in a 30-day period. And now that we've seen an example and kind of worked through it on paper, let's talk again about what's really happening when we add in y as a variable. Like we said in the previous video, the introduction of x brings us to the first dimension, because it gives us a line, which essentially has infinite length going in either direction. So what y does is it adds another line, except instead of being a horizontal one, y will be a vertical line. And this vertical line will allow us to move from the number line, which was our one horizontal line represented by x, to what is known as the Cartesian plane. Another word for it is the coordinate plane. It's sometimes referred to as the Cartesian plane because there's this guy named Descartes who is pretty famous for coming up with this idea, so we named it after him to give him credit. But we'll probably refer to it as the coordinate plane as well, and that might be an easier one to understand as we talk about what coordinates are here. So coordinates are basically where to find something, and like we just talked about, we have this coordinate plane, so the plane itself is where you can find these things. So what are the coordinates, you might ask? The coordinates are going to be your y value and respective x value. Or you could think of that the other way around, since we've been working from x, your x value, and then what that makes the y value's output. So we call these coordinate pairs because they're pairs, like in the equations that we've been solving. When I plug in a value for x, I get a particular value for y. So that pair would be the input for x and the output for y. The easiest way to see this visually is if you go back to the table that we talked about previously. For every x value, there is a paired y value on the table. So you could just look at the x and y values at any point on the table to know what the coordinate pairs are for that position. But what's really important here is that we're moving into the second dimension as we do this. As we talked about before, the number line was the first dimension, and this plane, this coordinate plane, is now the second dimension. And you can really think of the second dimension as kind of any flat surface. So like a piece of paper, everything we write on a piece of paper would be considered to be written in the second dimension. And hopefully, to make this even more clear, we live in the third dimension, because I can move to the left and to the right, and I can move forward, and I can move backward, and I can jump up and down. So there are 3 different directions that I can go in. Right now we're in the second dimension, so we can only go up and down or left and right. In fact, if you took something like a water bottle and placed it on a piece of paper, you could think of the water bottle as being that line that adds depth to the third dimension. In math, we would call that line z. So we would have x, y, and z in the third dimension. But that's getting too complicated, and we're not going to talk about that now. There are a couple of important things to point out, though, now that we recognize that we're in the second dimension. The most important thing is probably that we can now make shapes. So now we can have squares and triangles and rectangles and things like that because we can measure both height and width. Because, like we said before, we now have 2 dimensions that we can measure. The other thing is that we're going to introduce something that we can measure now that we couldn't measure before. So if we think about what we measured before, it was basically always length. You could say height and length, but essentially it was just one number. And now that we've added the second dimension, obviously we can find 2 numbers, so like height and width or height and length. But another thing that's really interesting is we can measure rotation. In order to measure rotation, we've got to learn a couple things first. The first thing that we have to learn is what a vertex is. Anytime you have 3 separate points which are connected by lines, the middle point will always be the vertex. The vertex is where we're going to look to figure out how much we've rotated. When we look at the vertex, there will be 2 lines coming out of the vertex. Those 2 lines determine how much rotation has taken place. You've maybe heard this before, but an entire circle, so one full rotation of a circle, is 360 degrees. So that means you start at one point and then you rotate all the way around back to your starting point. That would be 360 degrees of rotation. And that wouldn't look like much because it would just be the same line. In the same way, 180 degrees wouldn't look like much either because it would be a flat line, so it would still just look like one line. Because remember, 180 is half of 360. So instead of doing a full circle of rotation, we do a half circle of rotation. And then maybe the most recognizable would be 90 degrees of rotation, which would basically be going from laying down sideways to standing straight up. This 90-degree rotation we actually see all the time in our lives. In fact, if you just look at a wall and follow it to the floor, it more than likely has a 90-degree angle. And you'll notice that I said angle instead of an amount of rotation there at the end. And that's because if it's already there and we don't have to rotate to get there, then we just call it an angle. So like I said with the wall to the floor, you don't have to lift your wall up and make it a 90-degree angle to your floor. It just already is. So we would look at that and say, this is a 90-degree angle to the floor. Angles are all over the place, and a lot of the time we work with them with shapes. In fact, if you think of the name triangle, a triangle is just three lines that make up three angles when they're connected. And that'll do it for this video. In our next video, we'll get a little more into these shapes and angles before we get back to some more functions with y. But until then, remember to like, comment, and subscribe, and we'll see you in the next one.